Hi and welcome to the course on ethical hacking. We are covering techniques, tools, and countermeasures, and the topic that we are going to cover today is about attacks, web, and databases. Now, in order to understand the web and database attacks, we must know that companies nowadays are hosting everything on a website. For example, if you have a website and you are selling certain items on the website, you'll be posting information about all those items on your website. Now, the information about all those items usually is contained in the database, which is linked to your website as well. Now, that's a very attractive thing for the attacker to penetrate in the website or in the web server in order to get all the information which is available on the company website and defacing its website for stealing that information. Now, it is a responsibility of the information security professionals to have a balance in between the information which is posted on the website so that the information is available to the users and is equally protected against any sort of attacks that we may face in now or in the future as well. So it's the responsibility of the organization to make sure that the information which is available on the website is secure, and even the content which is posted over there is safe from any sort of contamination as well. So first of all, we'll see that what are the key concepts that we'll be covering. So in this chapter, we'll be talking about web server vulnerabilities and exploits. Then we'll talk about web application and their vulnerabilities and exploits. And at the end, we'll be talking about database attacks and the tools which are used in order to launch those attacks. Now, the learning objectives of this chapter is that we list some issues related to web servers. We discuss the threats to the web application, vulnerabilities of web servers and web applications. We'll be looking at the challenges faced by the webmasters, and we'll see some ways how the websites are defaced and the ways to ameliorate the web services. We'll be describing the attacking or how the web applications are being attacked. Further, we'll explain the nature of the buffer overflows and what are buffer overflows. Then we'll explain the nature of the input validation, that why is it important to check and to validate the information which is being passed from the web pages to the databases. We'll list the methods used in denial of service attacks for the websites, etc. Then we'll be looking at the SQL injection, and we'll identify the security issues which are associated to cloud computing. Now, we'll be briefly talking about cloud computing in context to the web and web applications and database. Now, when we talk about attacking a web server, the three organization roles will interact with or be concerned about the health and well-being of a web server. First of all, there will be a server administrator, and then the network administrator, and finally we have a end user. Now, as we discussed earlier, that your website is the primary face of your organization because the customers are usually visiting your website, and if an attacker takes over the website and he posts certain information on the website, that would circulate a very bad reputation of the organization in the public. Now, when we are talking about the organizational roles who will interact with or will be concerned about the health and well-being of the server would be server administrator. Now, the server administrator is usually concerned with the security of the server because it can provide an easy means of getting into the organizational internal network. The web server may potentially act as the entry point of the network for various types of malicious codes such as viruses, worms, trojans, and the rootkits, etc. For server administrator, this problem represents even more of a challenge because when the servers have been increasingly complex and we have quite a rich amount of information available on the servers, with unknown or undocumented options that are left unaddressed, we are opening a door for the penetrators to attack and penetrate in the systems. Then we have network administrators. They are concerned with securing the network infrastructure and resources that are hosted over there. Any security issues which are related to the web servers or the weaknesses can lead to exploits and result in attacking or gaining access to the network resources and other hosted applications further to the other connected servers with this server. Network administrators are aware that the web servers need to be usable by the public and therefore accessible by the means, or it should be available to the masses, but at the same time secure it so that the information which is required only, shall be available to the end users. Rest of the information should be kept intact. Now if someone would penetrate in a server, for example, now they look for the other adjacent servers which are on the same network, and he'll scan for the IP addresses and the open ports, etc., for rest of the servers, and they'll try to penetrate on that also. Then we have end user, the person who interact the most with the server, concerned mostly with the access, the content and the services, etc. Regular users just want to browse the site and access their desired content on the website, and they are not concerned about what sort of Java version is there, if Flash is being used or not, or what are the security issues and how they are handling with it. Making security more of a top of the mind issue is in fact that their use of the web browsers to access the web content can allow the threat to penetrate the internal network also. So it's not only about the security, the users must be concerned about the browsers and other things that they are using as well. Now there are different categories of risk as well. Now in the categories of risk, first of all we have server defects and misconfiguration. So if the server is not configured in a proper way and the end user can run certain scripts and execute some things remotely, or can enumerate the servers, they can even carry out the denial of service things on the servers as well. Now attacks in the space are generally associated with the type of the attacks a server administrator or webmaster would encounter. Now browser and network based risks are, these are the risks which include an attacker capturing the network traffic between the client browser and the server. When we talk about browser and client risks, we are talking about the risk which affects the user's endpoint system directly, such as crashing the browser, stealing the information, infecting the client system, or having some negative effect on the client system. Now we have different categories of vulnerabilities of web servers, like we have improper or poor web design, then there is buffer overflow, denial of service, distributed denial of service, banner information, permissions, error messages, unnecessary features, user accounts, and structured query language, which we call as SQL injections as well. So now we'll try to understand each of them separately. So if we are talking about improper or poor web design, comments or hidden tags in the web pages are potentially dangerous vulnerabilities and are not displayed in the browsers, but is moderately savvy attacker can view the sites and can examine the source code of the page. Now that's really simple, that how can we easily see the source code or the code which is behind the page. Hypertext markup language source code includes some information that might prove useful to an attacker. May not be completely actionable, but could provide some useful information for pre-attack reconnaissance, etc. Now if you want to see the source code of a page, it's really simple. You'll right click on the page and then you'll click on the option called view page source, and it would show you the HTML code which is behind that page. Now here also, as you can see, that they are posting a comment over here which is a basic information about the website. Sometimes when developers are developing the web page, they forget to remove these comments from it, so that they actually comment it since they are developing the page and they want to understand it after developing the entire page. Usually these comments are removed from the website. So these things should be taken care of, that all such things shall be removed from the page before they move to the production servers. Now that's an example of an HTML page where there is some information about the HTML page. As you can see that it includes some information that might be useful for an attacker. It might be completely actionable, but it does not provide some information that could be useful during the pre-attack reconnaissance. For example, in the page, notice the presence of the email address and even what appears to be the payment processing things, etc. This is the information that can be used where the attacker can plan something in order to launch any attacks over there, as the email address is appearing right over here. Now in next page also they are giving an example of it for the vulnerability in the HTML code which can be exploitable. For example, here you can see the address of the page plus the method is also mentioned, the price of the item is also shown, and the length and rest of the details. Web designers use hidden fields to hold the price of an item. Now, any attacker could change the price of the item from 6,000 or 60 or $6 to make a discount here on its own. Next, we have buffer overflows. Now, buffer overflow occurs when an application processes a program attempts to put more data in a buffer than it was designed to hold. So there is a size of a buffer. If the data which falls in that bucket more than the size of the data, it would overflow. A programmer, either through lazy coding or other practices, creates a buffer in code that does not put the restrictions on it, like too much water poured into an ice cube tray. The data must go someplace, which is in this case means that the adjacent area of the memory. It can also result in corrupted or overwritten data, loss of the system integrity, and disclosure of the information to unauthorized parties. After that, we have denial of service attack. Now, in denial of service attack in which a web server resources are rapidly consumed, slowing down the performance of the server in mostly desired, an annoyance, and the possible to stop by blocking the identified source or the network subnet or the sources from which the data or the traffic is coming. Now try to understand that as a fixed asset, a web server is vulnerable to this attack much as any other server-based asset would be. Now when a DOS attack is carried out against a web server, all of the available resources on the server can be rapidly consumed, slowing down the performance. A DOS attack is mostly consumed and annoyance because it's very easy in most of the cases, and it can be defeated. Now, if it's a simple DOS attack, it can generally be stopped by just blocking the traffic or by the IP address, etc. But if the traffic is coming from multiple sources, it becomes a little bit challenging to take care of it, which happens in distributed denial of service attacks. It consumes all the resources on a server and prevents the server from being used to the legitimate user. So it would take all the resources of the server. If the end users would try to access the server, since there are no resources available, you'll not be able to reach the server. Now, accomplishes the same goal as denial of service. The difference is the scale, because in denial of service there is attack which is coming from a single source, whereas in distributed denial of service it is usually coming from multiple sources. Many more systems are used to attack the target, crashing the system the way of the multiple request environments, and much more difficult to control than the DOS attack, because distributed denial of service attacks are numerous and can change quickly. So they can easily change their IP addresses and their locations from which they are operating, but combined they'll try to take down a server by overwhelming its resources. Now, another thing which is associated with denial of service is the possibility that why there is with the rise of Internet of Things devices, which are generally uncontrolled, is a growing concern as well. Since IoT devices are commonly deployed without being hardened, attackers now have the access to millions or small computers from which they can launch distributed denial of service attacks. There are lots of different ways through which they usually launch the attacks. Some of the examples of distributed denial of service are ping flooding attacks, Smurf attacks, SYN flooding, or ICMP fragmentation attack. Now, in this attack, which is ICMP ping attack is also called, as we are talking about ping flooding attack, lots of packets are sent from another system with the intention of uncovering, for example, the information of the remote system. Now, this attack can be scaled up so that the packets being sent to the target will overwhelm it, and once it's received over there, it would force the system to go offline or suffer the crippling down, slowdowns, etc. So lots of packets will be going. It would be trying to get the information about the system, if it's up or not, more than the regular size which usually goes over there. Smurf attacks are similar to the ping or the flooding attack, but with a twist that in a Smurf attack, the ICMP packet is sent with an intermediate network where it is amplified and forwarded to the victim. In this way, a single ping becomes a virtual tsunami of traffic, where the computer will not be able to handle that much of traffic, because it is not meant to withstand that much of traffic which is coming to the system. Then we have SYN flooding. It is equivalent to sending a letter that requires a return receipt, just like in case you are, for example, sending a letter to a party and you are waiting for a response for that. The return address is bogus in this case. So in a return receipt is required and the return address is a bogus, the receipt will go nowhere and the system will be keep on waiting for the confirmation with an open request that would be left in a limbo, and some period of time an attacker who sends enough SYN requests to the system can use the connection on the system so that nothing else can go through. So if you send a SYN request, of course you are waiting for a SYN ACK, and then if you're not receiving that, the port would remain open waiting for the response from the other machine, and if it will not receive it, it would keep on accumulating with the passage of time. Then we have IP fragmentation attack. In IP fragmentation, it requires an attacker to use advanced knowledge of the TCP IP suite to break up the packets into fragments that can pass most of the intrusion detection systems. In extreme cases, this type of the attack can cause the service or the system will freeze up, or it would lock up, or it would reboot the systems, or blue screens will be there. So it can create lots of problems over there as well. After that, we have a thing called banner information. Now a banner reveals the information about a web server. We connect to a port 80, for example, on a web server, and that's the banner information. For example, it is saying if we are trying to telnet a server name, for example, anyserver.com, it is usually going to port 80 of the machine, and that's the result of it, that if you're trying to connect to an HTTP machine, it would be a server name, the current location, IP address, and the HTML page, etc. details, and it details like the current date, content type, except ranges, last modified, and all that related information will be displayed over there. Now there are lots of tools that you can use in order to gather the information. As they are using Telnet, there is another tool which we call PuTTY that can be used in order to gather that information as well. After that, we have permissions. In permissions, the control access to a server and its content should be verified. It can easily be incorrectly configured, so special attention must be paid for the permissions which are there. Now, incorrectly assigned permissions have potential to allow access to the locations on a web server that should not be accessible. Older web servers allowed access to the directory traversal, where they were able to get the root access of the server where the website was actually hosted. An attacker could enter the path such as // etc., some file, etc., and it can access the files which are stored on the server root directory. Now, incorrectly assigned permissions have the potential to allow the access to the location on the web server that should not be accessible. Most web servers allow the users only to read or write, or a very limited number of locations on the web server which will be allowed to access the information. Next thing that we have over here are the error messages, which are usually shown by your IIS. For example, there would be a message number and there will be a corresponding description of that. Now that's a standard way of handling the different error messages on the page, but sometimes these error messages would show way too much information about the actual problem or the things which are related to the web server. Now, if you have configured, as we have seen in the other course of cloud computing, that how can we configure a web server, we even showed that how can you change these error messages which should appear on the website. Now, if you have changed the error code of the messages and the description of it, maybe only the error code would appear on the website, with the help of which you'll be able to understand that what's the actual problem without disclosing way too much information on the website. Now next we have over here as unnecessary features which shall not be allowed on the server. If you're not using that, if you're not using those roles and features on a website, you must change or remove those permissions from the server so that the other person shall not be able to gain any access to your website. Now server should be purpose built to the role that they will fill in the organization. Anything not essential to this server should be eliminated, hardening or removing the feature, services and applications that are not necessary for a system to do an appointment job. If a feature or a service is not needed, it should be disabled, or better, don't install it at all. Now as you can see, this is my Windows Server 2022, as they are talking about that unnecessary features should not be there. So if you'll click on your server manager on your server, you'll go to manage, and there are different roles and features on the server itself. Now if you'll press next and you'll go to the features which are available on this server, you'll have to make sure that you are installing only those roles which are required for your server. Now as you can see, there are lots of roles. If you don't need them, don't install them, because you'll have to check the settings and permissions of each and every role that you have installed, and if there is a vulnerability identified in any of the roles for that you have not properly configured the policies and the security of it, there are high chances that your server will be compromised. Now we have user accounts. Today's operating systems install a number of default user accounts and groups to allow the computer to work out of the box. These accounts can easily be discovered through the research by the attacker and can be used to gain access. Now security best practices is to disable, remove the default accounts and create the new accounts that correspond to an administrator will use for the services, etc. Now there are default accounts which are there in Windows. Now if you are creating, or you have just set it up an operating system on a system, it's your responsibility to make sure that create the accounts, make sure that you are regularly changing the passwords, and don't name the accounts as admin or administrator. That would give a clear idea to the attacker, even if he'll try. Those are the two common username that they would try, that if admin or administrator account is over there, maybe you can have an account which is an administrator account, but it would be of a generic name. Now next we'll be talking about structured query language, which we call as SQL injection. It's designed to exploit the applications that have access to data stored in the database. Now attack injects the SQL code in the input box from the network packet. Now SQL commands can be exploited. Unvalidated input vulnerabilities in a web application or a database is used to execute arbitrary SQL command through the web applications. Now since your interface when you are interacting with the website is through a web interface of the application. Now if you want to interact with the database, you will be going through that web interface, and if it is not designed according to the right principles and security features of designing an application, there are high chances that users can insert the information in the admin username and password and can extract lots of information by executing a SQL structured query language or a normal query through the field, and it would result in giving lots of other information which is related to the database right on the screen. So in order to stop it, there should be a focus on the input validation of the data which usually goes through the website. Now, SQL injection vulnerabilities are a serious issue for a website that uses a database as the backend. Attackers with a sufficient knowledge can easily detect and exploit the flaws in the web application, web browser, web servers, and databases, etc. because many websites uses database as their backend to provide rich experience to the visitors. This kind of attack can affect the small scale sites as well. Now SQL injections are carried out by placing special characters into the existing SQL command that modify the normal command behavior to achieve the attacker's desired results. There are lots of examples of that we'll be looking. One of them, which is quite simple over here, which is talking about the normal attack. I think it's in the next slide. If a website lags, we have already covered it, and we'll be showing you the information which is related to that an attacker would enter a username key and enters the string for the intername. It would be name, delete the items from items, so it would be deleting all items from the items. The query would become that select the all items from the items where the owner is this and the item name is name, delete all items from the database. Now if you'll focus on this one, you'll see that the data entered for the item name does not have a leading single quote, but does have a single quote after the string name. The attacker uses the single quote to tell the SQL that the command is finished, and then the attacker adds the completely new command that deletes all the records in the table. Now, many of the well-known SQL management systems or SQL database management systems such as SQL Server allow multiple SQL statements separated by semicolon to be executed at once. These techniques, now which formerly known as the batch execution, etc., allows the attacker to execute multiple arbitrary commands against a database. In other databases, they do not support multiple commands, but the technique will generate an error, or it would show say that it failed. So knowingly the database you are picking is an essential database, that whether it is SQL or MySQL database, etc. If an attacker would enter this information, he'll be able to delete all that information from the database itself. Now we'll see some more things which are related to the security of it, which is vandalizing a web server. Now there are lots of things which would vandalize the strength or the security of a web server. For example, credentials through man-in-the-middle attacks, etc. Brute force attacks on the administrator account, file transfer protocol, web server vulnerabilities, web folders, incorrectly assigned or misconfigured permissions, SQL injection. Then we have URL poisoning, web server extension exploits, and the remote server exploits, etc. After that, input validation plays an important role whenever we are talking about the data which passes through the website or gets some information from the database. In most cases, user enter the data in a form of a website will have few, if any, restrictions on the data or the data which is being fed through these forms. When the data is accepted without restriction, mistakes and malicious input will be accepted by the system and will most likely lead to problems, etc. Now, the signs of corruption that you would see in case if there is a problem of the data or the data which is stored on the database, the system would crash, unexplained application actions would be there, database corruption, or maybe inconsistent data would be saved in the database itself. For example, if you have a form and there is an input field for the name, if a user would enter the phone number over there, and if it is accepted, it means that there are no security procedures which are saved on the application and the database through which the end user or the attacker can gain access to the system itself. That's why whenever we are defining the applications, we pay a special attention on the field what is the actual data type which should be saved on that field, and the data type is defined on the database as well as on the application through which they are trying to enter the data. Now we have cross-site scripting attacks. Cross-site scripting attacks are quite common these days. Now these attacks are like they usually rely on the variation of the input validation attack, but the target is different because the goal is to go after a user instead of an application or the data. For example, the cross-site attack might use scripting method to execute a Trojan with a target as a web browser, or a cross-site scripting attack would be possible by using a scripting language just like Java or PHP. By conducting a careful analysis, an attacker can look for ways to inject the code in the web page and to gain access of the session information in the browser and to gain the elevated privileges on that machine. Now here we are just giving an example that the attacker discovers the Hyrule website, which is a website suffers from a cross-site scripting. The attacker sends an email that the victim has just been awarded a prize and should collect it by clicking on the link. So it's a phishing email that they have received. Now the user would have the email with a script which would be written embedded inside the link which is there. When the user would click on the link, the website displays a message "Welcome back" with a prompt to enter the name of the user. Now after that, the website has the name of the browser. From the browser, it would take it from there and it would appear as if it is a legitimate script because it took the details from your browser. The web server reports the name returned to the victim's browser. The browser then correctly interprets this as a script and would execute it. Now this script will instruct the browser to send a cookie containing some of the information of the attacker system, which it does. Of course, the cookies are maintaining all that information about you and the session which is in progress, etc. So that's how they try to gain access to the machine through the browsers, etc. Now we have anatomy of the web applications. Exploitable behaviors include that the theft of the information such as payment card and sensitive information can be taken, the ability of update the application and site content, server-side exploits, buffer overflows, domain name system attacks, or destruction of data would take place. Now applications such as Microsoft, SharePoint, Moodle, which is a content management system or a course management system, and many others have embraced all for all sort of reasons ranging from organization or the data stream to the customer's access, etc. The applications in this category are typically designed to be accessed for the web browser, and similarly the client application which we access like HTTP protocol, etc. to exchange the information between the client and the server. So that would lead to the leakage of information. Now many applications or many web applications even more of a concern to the security professionals, in fact that many of the applications are dependent on one or more databases. Web applications manage a variety of information such as configuration information, business rules, logic, and customer data. Using the attacks such as SQL injection, an attacker can compromise the web application and then reveal or manipulate the data in ways that an owner may not have the information, or they'll not even know that the information has been leaked. Now there are some common vulnerabilities of the web application that tend to somewhat specific environment, including the factors such as operating system, application and end user space, etc. With these factors in mind, with the web application vulnerabilities can be roughly organized into the categories as the authentication issues. Then we have authorization and configuration, session management issues, input validation, encryption strength and implementation, and environment specific problems. So we'll have to take care that we are deeply looking into authentication issues, like if they are happening, why they are happening, if someone is remotely trying to access your computer, if there are any authorization configuration that someone who's not allowed to access those systems is still accessing the systems, session management issues, that if a user is signed out, if you have copied the URL of the page before sign out, if you are posting it again in the browser, it should not open that page since the session is expired. Input validation should be there, that you should not be able to enter the alphabets in the field which requires numbers. Encryption strength and implementation method should be there, that you should be using the algorithms which are safe enough and they are declared that they are not they are the latest ones and they don't have any flaws. Then you must have the environment specific problems. Keep an eye on that as well. Now there are some insecure logon systems as well. Now that means that the error message which appears on the screen shall not provide way too much information about the data that you have entered. It should just say a vague thing that the information is not found, or maybe contact the system administrator. If you'll say information not found, they'll know that the data that you have entered is not available on the database. Now they can track the information which is related to the error messages over there. For example, entry of an invalid user ID with a valid password, entry of a valid user ID with an invalid password, or entry of an invalid username ID and a password. So if you are displaying a message that the user not found, the attacker would know that this user does not exist on the database. Or if you will say that wrong password, it would detect that since the username is okay, it's only talking about the wrong password. So now he'll work on guessing the password of those applications. Now next is scripting errors. In scripting errors, web application programs or code such as CGI, ASP.NET, PHP, Ruby, Perl, and JavaScript or Java server pages are commonly in use in web applications and present their own issues. Now, lack of input validation scripts and the support of SQL injection can be a liability to these applications. Now, there are different methods used by the attackers to cause grief to the administrator or the web applications. They are upload bombing, poison null byte attack, default default scripts, sample scripts, poorly written or questionable scripts. Now, if we are talking about upload bombing uploads masses of files to the server with the goal of filling up the hard drive of the server. Once the hard drive of the server is filled, the application will cease and the server would stop working or it would crash. If we'll talk about poison null byte attack, it's a poison null byte attack passes special characters that are usually scripts may not be designed to handle properly, and in such cases the scripts may grant access where it should not otherwise be given to the end users or the attacker who is trying to gain access to that server. Default scripts are uploaded to the servers by the web designers who do not know what to do or the fundamental level. An attacker can analyze or exploit the configuration issues with the scripts and then use them to gain unauthorized access to those servers. Now, sample scripts are the web applications may include sample scripts or content scripts that are regularly left in places on the server. These scripts may be used by the attacker to carry out any sort of attacks. Now, poorly written or questionable scripts means then some scripts include the information such as username and passwords, potentially letting the attacker view the content of the script and read these credentials from there. Now we have session management issues. In session management issues, sessions represent the connection that a client has with the server application. So once authentication takes place and there is a handshake between the client and the server, that secure communication which takes place between the client and the server is called a session. Session information can give the attacker access to the configuration or the confidential information if it's compromised. A session has unique identifier, encryption, and other parameters which are required to carry out a proper communication between two parties. Now we'll see some of the session types which are there. Session management issues, vulnerabilities associated with the session, for example, long-lived sessions, logout features, insecure or weak session identifiers, granting session ID to an unauthorized user, absent or inadequate password change controls, or inclusion of unprotected information in cookies, etc. Now, long-lived sessions are the sessions between client and server. It should remain valid only for the length they are needed and then shall be discarded. Now, the sessions that remain valid for the period longer than they are needed allow the attacker to gain access, and then which would lead to cross-site scripting that would, with the help of which they'll be able to retrieve the session identifiers and can reuse the session for their own gain. Then the logout features, an application should provide a logout feature that allows the visitor to log out and close the session without closing the browser. So it should not be a requirement that you should close the browser. Once you're logged out, all the related session cookies shall be cleared from the browser so that no one else must gain access to the system. Now, insecure or weak session identifiers, session ID that is easily predicted or guessed, can be used by an attacker to retrieve or use the sessions that used or that should be closed. Now, some flaws in the web applications can lead to reuse of the session IDs, etc. Now, granting the session ID to an unauthorized person, sometimes applications grant session ID to unauthenticated users and redirect them to a logout page. This can give the attacker the ability to request valid URLs which are usually maintained at that level. Now, absent or inadequate password change controls, an improperly implemented or insecure password change system in which the old password is not required allows the hacker to change the password of the other users. Now, you might have seen all those old applications that we were using before, in that it does not ask you for the old password, it would just ask you to enter a new password. So if they have bypassed that stage, anyone can enter a new password and can gain access to the system. Now, inclusion of unprotected information cookies, information such as the internal IP address of the server, can be used by the attacker to ascertain more about the nature of the web applications, etc. Now we'll be talking about different encryption weaknesses, etc. Now, there are weak ciphers and there are vulnerable softwares. Now in the web application, encryption plays a vital role because sensitive information is frequently exchanged between the client and server in form of logins and other types of sensitive information. When working on securing a web application, you must consider the safety of the information at two stages. First of all, when it is being stored and when it is being transmitted. Both stages are potential points of the attacker and must be thoroughly analyzed by the security professional. When considering the encryption and its effect on the application, the following areas are of a concern, which we say as weak ciphers and vulnerable softwares. Now, weak ciphers are the coding algorithms use short keys or poorly designed, or if they are poorly implemented, it uses such weak ciphers that can allow the attacker to decrypt the data easily and gain unauthorized access to the information, etc. When we talk about vulnerable software, some software implementations that encrypt the transmission of data, such as the SSL, may suffer from poor programming. On the other side, the consequences of it would be that they may be vulnerable to the attack, such as the buffer overflow, etc. Now we have the database vulnerabilities, but before that we'll have to see that there are lots of tools with the help of which you can check the overall security of the application that you are hosting on your website. For example, you can use OpenSSL. Now, as you can see, I have opened OpenSSL website. It's an open source toolkit. It is used to implement SSL v3 and TLS protocols, etc. So you can get the details about that from here. Then we have the other one, which is OS, which we say as Open Worldwide Application Security Application Project. Now this one is a cryptographic cheat sheet is available on that. You can get some details about that and the cryptographic algorithms which are quite famous these days. Then we have Nessus Scanner, which can list the ciphers in use by the web server and find many vulnerabilities that exist in many of the computers and devices, etc. A very good tool to be used for the vulnerability assessment, etc. Then we have OpenVAS. It's an open vulnerability assessment scanner, an alternative to Nessus, which is a security scanner that can identify many types of vulnerabilities in the IT environment, etc. After that, we have Nikto. It's an open source web server scanner that helps uncover wide variety of web server vulnerabilities, etc. So you can use it as well on your machines. And finally, we have another one, which is Tunnel, which somehow it's not opening at the moment. And Tunnel is a program that allows the encryption of non-SSL aware protocols, etc. So that's how we can get some information about that. Now we'll be talking about the database vulnerabilities. Now the database contains the information about the website, application of the organization, and they are quite attractive to the attackers, as we talked about in the starting of the chapter. Now databases represent the holy grail, the attackers, because of the information within them, configuration information, application data, and all sorts of shapes and sizes, because nowadays with the content management systems, you are saving everything in the database. So your web interface is just a web interface through which you are accessing the website. Rest of the information related to the pages, links, all the pictures, statistics, and all the related information which is shown on the page, all that related information is usually saved in the database. Now most web applications could not function without a database, as their backend is a database. Now there are different types of databases. We have relational database and we have non-relational database. A relational database stores the data logically as a connection or as a connection of tables. Each table is in relation to the database, looks like a spreadsheet format. Data can be organized and accessed in different ways as appropriate for the situation. For example, a data set containing the customer order might be grouped by the postal code in which the transaction occurred, by the sale price, or by the buyer's company name, so that you can sort the information according to the format that you are looking for. Now the user issues the queries to the database using the query language, which we call as structured query language, to fetch the data, where it can modify the data in one or more tables, and it can also bring the data collected from different sources, combined it all together and present it on a screen. Now we have non-relational, non-SQL database. The extremely large volume of the data is available today often exceeds the capabilities of the relational database management systems to efficiently process it. Now NoSQL databases come in different varieties. With key value storage technique being quite popular. With the key value approach, instead of grouping similar data into rows and columns and relational databases as we have seen in a SQL server or MySQL database, non-relational databases store each data element as a value with a key used to retrieve that information. Now NoSQL data stores such as Hadoop, we covered it earlier, and Cassandra, that's another database which is used, grew out of the need to store and retrieve massive volume of data in extremely short period of time. Now Google has made a great stride towards in this space to support the responsive search of the query and the data that we usually receive when we pass any kind of parameters. Now next we are looking at database vulnerabilities, etc. In database vulnerabilities, we have misconfiguration, lack of improper training, buffer overflows, forgotten options, and other oversights, etc. Now, database can have different myriad vulnerabilities that leave them potentially open for attack. These vulnerabilities are as varied as the environment in which the technologies operate. They include misconfiguration, lack of improper training, buffer overflow, forgotten options, and other side just waiting for an attacker to exploit. Now, before you can uncover the vulnerabilities in the database, it is necessary to know which database product your organization uses it and where is the actual database, whether it is on premises or it is stored somewhere in the cloud. Databases can easily be missed because they may be installed as a part of another application or just not reported by the application owner. For example, Microsoft SQL Server Express is a small free piece of software that is a part of various applications that a typical user may install. As such, this database may go unreported by the users who are unaware of the security issues which are involved in that. Now, you might have seen it when you are using Visual Studio. You don't install any SQL server over there. It is using a light version of SQL, which is an SQL Express, and you are testing and making your applications using that small database which is there. Now, locating a database is very important on a network. Now, there are different tools for that. Network database scanners are there. With the help of that, the penetrators or the persons who are looking for certain information will be able to find the databases on the network. They are effective for locating the rogue or unknown database installations. SQL Recon is one, which is similar to Network Database Scanner from Microsoft SQL installations. OmegaDB Security Reporter and OS Scanner for Oracle installations, etc. is there. We can see a basic application over there which is Network Database Scanner. As you can see, it is scanning the database on the network based on the ports which are quite common for different databases. For example, if your MySQL database is using port 3306, so it can only scan those ports if they are active on the network, and they can easily get that information that what kind of database you are using on your infrastructure. Now we have this database server password cracking. For that, we have different tools. SQL Ping, can enable, and dictionary based cracking methods are used in order to crack the passwords of the databases. After that, we look at locating the vulnerabilities in the database. Every database is prone to its own type of vulnerabilities, but some common ones can be exploited using the right tools. These vulnerabilities include, for example, use stored procedures, service account privilege issues, weak or poor authentication methods enabled, or no or limited auditing logs, etc. Now, if you don't have proper stored procedures, or you are using the procedures which are quite weak, or the service account privileges issues are there where you're not handling any sort of permissions that who must be accessing which things, weak or poorly authenticated methods, or limited or no audit settings for that, where no one is monitoring that who's accessing the database and what sort of information shall be there. Now, the software tools that are used to perform the audits of database are NCC SQL, and then we have App Detective Pro and Scuba, which are quite common in order to take care of the audit logs of the database. And now slightly we'll be looking at the cloud computing over here. It evolved as the means of offloading services from the local intranet to the internet services that have migrated to the cloud based on earnings. For example, if we are using email, scheduling, storage, infrastructure, and thousands of other services in the cloud, we are using part of the services which are hosted in the cloud. Reasons of moving to the services in the cloud is lower support costs, reduced internal resources, reduced personal requirements, increasing flexibility and capacity. We are covering a complete course on cloud computing which is available on our channel. So if you want to know in detail about those things, kindly visit our channel and look for the course on cloud computing. Now further, we have different cloud service models as platform as a service, software as a service, and infrastructure as a service. In platform as a service, you'll be deploying your applications in the cloud and you'll be using the tools which are provided by the cloud service provider in order to develop your applications. Software as a service is anything that we are accessing through the web like Zoom or Office 365, etc. that we are paying for that service, and we are accessing that service everything through the browser or through the applications, and we'll be able to get the data of us and our organization people who are subscribed to the same service. In infrastructure as a service, we can shift our entire data center to the cloud where we are not responsible for anything but to manage the data in the cloud. Now the security issues are availability, reliability, and loss of control, which are some of the common issues when you talk about cloud computing. And that brings us to the end of the chapter. We covered web server vulnerabilities and exploits, we looked at the web application vulnerabilities and exploits, and we looked at the database attacks and different tools which are used for that. That's it for today. Thank you very much.